and there's also a chapter, let's see here, 6, because we didn't do 6 at all. So we'll be doing 6 and 8. So we still have a bit more to cover, and we can still cover conic sections if we get there. So if we run through everything, we have conic sections also. And we'll cover that when we get there. There'll be a test over each one. So when we look at this here, well, x minus 2 won't factor or simplify. X plus 2 is also as simplified as it gets. Now, x squared minus 4, will that factor? Well, yeah, because it's a difference of perfect squares. And it would factor to what? X plus 2 and x minus 2. Right, the 9x squared won't reduce, but the x squared minus 4 will. And we need that reduced. We need that factored, because that's going to help us figure out what is the least common denominator. What is the smallest thing we need to multiply each one of these fractions by so that the denominators simplify. So while looking at 9x squared, well, I'll need an x plus 2 and then x minus 2. Well, that means we've got to multiply it by everything else as well. So that one, the x plus 2 and x minus 2, takes care of the one on the right. It takes care of everything on the right, actually. Right side of the equal sign. Now, is there anything on the left side that we need to add to it? When I look at the first term, 9 over x minus 2, well, the x minus 2 and x minus 2 would cancel, yes? Anything left on bottom? No, so we're good there. Let's see here. X plus 2 and x plus 2 would cancel. Do we have anything left? Nope. And both of these will cancel out with both of these. So do we have anything left in the denominator once we multiplied through? No, so we got it. Unlike the one we finished with, bless you, unlike the one we finished with yesterday, where we ended up doing our multiplication of those two, and we had one left over, we've got everything taken care of. So let's see what's left, or left after we did that multiplication. Well, we have 9 times x plus 2 plus 6x. 9x squared. Yes. So really, as nasty as these things looked, we did one main step. We did that multiplication of least common denominator, and it's turned it from something that looked nasty to back into quadratics, which we are comfortable with. Yes? Okay. Now what? Yeah, we would distribute the 9. We want to reduce or simplify out these sets of parentheses. Well, 9 times x is? 9 times 2 is? Plus 18. Yes, 6x squared. 6x times x would give us 6x squared. And 6x times negative 2, negative 12x, yes, equals 9x squared. Now we can combine some like terms. Well, 6x squared is by itself on the left side. We have 9x minus 12x, which would be negative 3x plus 18 equals 9x squared. Okay. So we have this set up here. And again, when we talked about this yesterday, I said we really want to try to keep the x squared, the term with the biggest exponent, positive, yes? Well, to do that, I'm going to have to move everything from the right to the left. I've got to move the 6x squared over. I've got to move the negative 3x over. I've got to move the 18 over, yes? That's going to be a lot of moving things over, wouldn't it? Right, because I can move the 9x squared over to the left, yes? Do we have ways to make it positive? Well, yeah. We have one specific way. Wouldn't be one, it would be, and I'm trying to make a symbol, but because it's not, yeah, -1. Because if I multiply a negative by a negative, yeah, I know, it's almost looks like I'm pointing at my finger. Yeah. Yeah, so if we have -1, because if it does, it will make the x squared negative, but if I multiply it by -1, it takes it from being negative to being positive. And there's these, we can do this, because this multiplication of a negative or adding or multiplying and dividing aren't changing the solutions. It's changing everything else around them. So we'll still have the same solutions. We just have to do another step. So if I wanted to move everything from the left side to the right, it's going to take me at least 1, 2, 3 steps. But manipulating the numbers, I can subtract 9x squared over. Is 9x squared minus 9x squared would become 0. 6 minus 9x squared, well, that's negative 3x squared minus 3x plus 18 is equal to 0. 3, yes. So once we did that, well, okay, we have 3, 3, and 18. Those are all divisible by 3, yes? So with these here, I can factor out a -3 from all 3 terms. I can divide a -3 by all 4 terms. Either one is going to do the same thing. So I'll show you this here. So if we factor out a -3, if I factor that out, let's see what I'm left with. Well, -3 factored out of -3x squared leaves me with plus x, because the -3 factors out completely and it changes its sign. Now, since the 18 is positive and I pull a negative out, it makes it So we got this here. Now, when we were talking, because I mentioned this yesterday, and when we brought it up, we could divide by a number, right? And how I said here, because I said it again today, we could factor the 3 out like we did here, or we can divide each of the terms by -3. It doesn't make a difference. And here's exactly why. Because our zero product property says if I have 2 things multiplied together and they equal 0, one of them has to be 0, yes? Well, I have -3 times this set of parentheses, yes? Is there any way I can make -3 be 0 by plugging a number in? Well, is there any way to plug a number into -3? Well, no, there's no variables, right? So that means -3 is not the part that can be 0. It has to be what? The x squared plus x minus 6, yes? That's what has to be 0. So this -3 is a scalar. It's part of the equation. But what are we really solving? The x squared plus x minus 6, yes? So that's why it's the same, because that's not what's making this be 0. It's this set of parentheses. It's not the -3. That's why dividing everything by -3 works the same as factoring it out. Okay. So we have it up front. Let's factor this thing. Since 6 is negative, our signs are what? Positive and negative. Factors of x squared. X and x, and the factors of 6. 3 and 2, and which one would be positive? 3 and the 2 would be negative. And again, as we said, when I have more than one thing multiplied together to be 0, one of them has to be 0. Well, we already kind of talked about it. Negative 3 can't be turned into 0 because we have nothing to plug it into. We have no place to plug a number in. So we're just seeing x plus 3 and x minus 2. And if we look at these here and solve them, well, the x plus 3, we would subtract 3 minus x is equal to negative 3. Here we would add 2. X is equal to 2. Yeah, it dawned on me just a second ago we didn't even touch the restrictions. Okay. So everybody good with these two answers before I go jumping back to the top? Okay, let's look back at the top. Right, because we have these here and these are just repeated. Well, x minus 2, that would be positive 2 because 2 minus 2 is 0. Negative, so that's with x minus 2. X plus 2 would be negative 2 because negative 2 plus 2 is 0, and that's what we have here. So x cannot be positive or negative 2. It can't be that value. Now, if the restrictions eliminate every single answer that we got, it is no solution. If our restrictions eliminate every answer, it is no solution because we don't have anything left. And it's really just saying the answers that work for it make the denominator 0, so there isn't a solution for it. How do we feel about these here? We feel good with these here, yes? We feel good with these here? Okay. I'm going to jump to this one here, the last one, because I feel like y'all have gotten the handle on this. So we're going to do one more of these here because it has a slight twist. There's a slight twist to it that I want y'all to see. But beyond that, these here, once we got that down, the fact that the least common denominator really simplifies these equations. They're not that bad. And that's most all of Algebra 2. Because once we see how it works, or how it breaks down, and we can use that to our advantage, it makes things a little bit easier to work with. Okay. So why didn't I write everything back there? Because I didn't write the x squared minus x minus 2. It can be factored, yes. All right, so this would be x plus 1 and x minus 1, right? No? We have a 2. It's not going to be 1 and 1. It has to be 1 and 2. Okay. Well, the 2 is negative, so we do have opposite signs. The factors of x squared would be x and the 1 would be positive, and the 2 would be negative. So that's kind of one of the little twists this time, because it's not factored out nicely, so we only had 2 sets of parentheses. Because I do know this one here would need to be multiplied by x plus 1 and x minus 2. Because we can kind of see that that's the only way that those would simplify. But if I do it to 1, I have to do it to the rest. Yes. So this one here has 3. Is it possible to have more than 3 that we have to multiply everything by? Could we have to multiply these by quadratics because they don't factor? Well, yeah. We could have any of these here, but Does the process change? No. The numbers change, but what we're doing doesn't. So look at this here. The x minus 1 and x minus 1 would cancel. Here, the x plus 1 and x plus 1 cancels. Here, x plus 1, x plus 1, x minus 2, and x minus 2. Let's see what's left over. So we have 2 times x. Wait a minute. We have x plus 1 and x minus 2, yes? That seems familiar. Wait, isn't that where I got that? Why don't we write it down? Yeah, and I mean, if you forget that that's what's already written up there, that's fine. There's nothing wrong with that. Because again, when we multiply those back together, it will go back to that point. It'll go back to x squared minus x minus 2. If we remember that, hey, it makes it a little bit easier. If we don't, it doesn't change anything. Now our next one is plus, well, x minus 2 times x minus 1 equals, well, x minus 1. If you're wondering, well, why didn't we do it with x minus 2 and x minus 1? It is because of the x minus 1 is not plus, because we had x minus 2 and x plus 1. It'll be similar to the other one, but the signs will be different. And the middle term will be different. So one of the first things, so if we're good at this point here, yes? We can multiply through by 2. Well, 2 times x squared is, and then 2 times negative x will be negative 2x. And negative 2 times 2 would be negative 4. Okay, now we need to distribute those two sets of parentheses. We don't have to put this in parentheses because this is plus, but it's a good habit to get into, just in case it's negative. Because if that was a minus, this thing here, everything inside of its signs would be altered because of it. So it's a good habit or kind of good thing to put it there just as a reminder, hey, once we finish multiplying this here, that negative is going to have to come into effect. So we can distribute the x first. X times x is x squared. X times negative 1 would be almost. X times negative 1 would be negative x. You're ahead. You're good. You're good. But now negative 2 times x would be negative 2x. You're one step ahead of me. Negative 2 times negative 1, and negative and negative would make a 2. Now you had it. It was just had them flipped. You're good. So 2x squared minus 2x minus 4. Now again, because it's positive, the signs aren't going to change. If it was negative, they would be changing. So we can drop those parentheses and combine our like terms. And so here, negative x minus 2x would be negative 3x plus 2 is equal to x minus 1. Let's combine some more like terms. Well, 2x squared and x squared would give me 3x squared. So we took care of those two. Negative 2x minus 3x, negative 5x, and negative 4 plus 2 would be. Okay. Well, we still have a quadratic, yes? We still have an x squared term. So we need to get everything on the same side. Can I do this? Yeah. So what did I do differently than what we normally do? Is there anything in mathematics that says that we can't? No. No, there's not. But the reason we don't do this normally, we can mix up the signs, or there's a lot written in there. But I know at this point, y'all have done this enough and kind of seen it enough, and we can actually write nicer than we did in middle school, I hope. But if this here is too much at once, we can do it in 2 steps. But if we can keep track of this, we can do it in 1. There's nothing that said we had to do it in 2. So if we can keep track of it and see, okay, we're doing this here, well, keep it in blue. We can do this in 1 step. Negative 5x minus x is negative 2 plus 1 would be. And this becomes?
Oh, I thought you said positive 2 minus 1 is equated.
Negative 2 plus 1, yes. Right, because we can do this in 1 step. Because if you've also noticed, you've been able to actually start looking at denominators and finding restrictions by looking at them, yes? Yeah, which we forgot to do. We'll get back to it. And I can tell you this is not going to hit any of the restrictions. So the next thing we need to do is to factor it. It does not have rational factors, which means we cannot factor it, but it doesn't mean it doesn't have solutions. So, what is the one way we know for sure to solve quadratics? The quadratic equation. So there are 2, there's going to be 2 on the assignment that are going to require you to use the quadratic formula. They are the last 2 on the assignment. But that just means at the end, you're just going to plug it in to the quadratic formula and solve. So when we look at this here, so x is equal to negative b, so negative, we'll make it a positive 6, plus or minus the square root of negative 6 squared minus 4. A is 3, positive 3, and C would be negative 1. All over 2 times A. Because 2 times 3 is 6. All right, highlighter. Now at this point here, we can plug all of this here into the calculator. Parentheses around the negative 6 squared minus 4 times 3 times negative 1. So it's going to be 36 plus 12 is 48. Yes. Hold on. There we go. 48. "48 will reduce." 48 will reduce. So if you're working on it in here in school at some point and get to these problems, the yellow calculators will simplify these out completely. Wolfram Alpha, if you want to use it and just do the square root of 48.
Yeah, it gives you 6.9.
Now, if we look at this here, because I can go and just check perfect squares, because 4 will divide into it, evenly. 9 won't. 16 and 16 is 32. 32 plus 16 is 48. So 48 is 16 times 3. I can't take the square root of 3. What is the square root of 16? 4. Wolfram, or not Wolfram. Big Ideas math on these two here are going to require, if you haven't noticed already, if it simplifies, it wants it simplified. Wait a minute, what do I notice about all three of these terms? They all have a common factor of? Guess what we're going to have to do? We're going to have to simplify it out. I can factor the 2 out of the numerator. Go to 6. If I factor 2 out of 6, I'm left with 3. Square root of 6. 2 over 6 reduces to 1 over 3. So we're left with 3 plus or minus 2 square root of 3 over 3. And that there is the answer. So again, like I said at the beginning, this one here, I wanted to do it because it had a little bit of a twist. And that twist was that our solutions were not rational. So when we think back to the top for our restrictions, did everything factor nicely? Well, yeah. So neither one of these is one of our restrictions, because it just isn't going to be like that. Our restrictions are actually plus or minus 1. Plus or minus 1 and 2 because of the x minus 2. Now, if you remember back to doing these when we covered quadratics, how annoying it was to probably type this into the graph or into Big Ideas Math on the Chromebooks. You know, a really easy way to do it, because they made you type it in twice. Yes, one for the positive, one for the negative case. Heck, you can type this onto the positive case, highlight it, and hit Control C, and it would what? Copy it, bump over the other one, Control V, paste it in, change the signs. But that's the only thing that changed, wasn't it? Was the sign in the middle. Copy, paste it, change the sign. Voila. Done for you. So questions on this here. Was this one here any more complicated than what we've been doing on the other ones? No. Yeah, they added in a quadratic. And that's what a lot of this stuff is, especially when you go on and take college algebra. Pretty much a lot of what we're doing, but they'll add that little twist. It doesn't change what we're doing, but it just making you think.